Okay, so, ladies and gentlemen, welcome to our talk, Beam Me Up, Application Development with HoloLens. So, this is a talk about augmented reality and having some kind of Skype calls with holograms. Yeah.
So, to introduce ourselves,
yes.
My name is Thomas Endres. I studied informatics in Munich, and afterwards we started creating these cool showcases. We have lots of them, and we will show you in a minute a few of them.
Yeah, my name is Förtsch, and we are working for TNG Technology Consulting, which is based in Munich. And yeah, I think let's start. What is this talk about? So, yeah. We get always inspired by science fiction movies. Yeah, so we are stealing. We get inspired by science fiction movies like Terminator or Avatar or whatever. In this case, we thought, hey, we want to have a phone call like it is at the Jedi Council. Yeah, and for this we need some kind of 3D camera like a Kinect, and we need a head-mounted display. In this case, the decision fell on the HoloLens. So we get filmed by a 3D camera, and this data gets directly streamed in our field of view. So this is how it should look like, somehow. Or not, Thomas? The force is strong with you.
Yeah, back in the year 2015, we already had our first augmented reality prototype. It was called the Augmented Rift, and it was something like a Terminator vision. So back then we had two cameras. These two cameras were streamed into an Oculus Rift. In this case it was a DK2, not the consumer version. And on top of that we had a 3D camera, and this 3D camera was used to augment the field of view. So here's how it looked like. So Martin is now in the field of view of the two USB cameras, and now we see the things that can be augmented. So first of all, we have the contours of the face, but we also had things like it recognized faces, so it could tell the name of the person, it could tell the emotion of the person, but also the heartbeat of the person, and so on and so on.
Yeah, measuring the heart rate was one of the most exciting features. Okay, so these augmented reality glasses were built 1 or 2 months before the HoloLens was shown to the public. So, but we are not working on this alone.
Yeah, so we have a complete team that is building these showcases with us. So here you can see the people who were involved in the development of the HoloLens project. And normally we start our projects at a so-called winter retreat. This is one day where we go to the Alps, and then we try to hack a solution, a first prototype within one single day. And it has been always this way since we started with, for example, the Terminator vision.
Yeah, so let's go to the agenda.
Yeah, the agenda will be, we'll have a quick introduction, we'll have a look at the code and technology, so what is used here, we'll show the fields of application, and then we have a conclusion, of course.
Okay, so let's have a start to the very first augmented reality device in the world. It was built by Ivan Sutherland and was called the Sword of Damocles. Built in 1965. Okay, so was built in 1965. Okay. 1, 2, yeah. 1965, Ivan Sutherland. Here you can see his very heavy device. It's attached to the laboratory ceiling and it weighs hundreds of kilograms just over his head. So this is the reason why it's called Sword of Damocles. Let's have a look. Here is a very old footage. You can see how he's holding the head-mounted display, and while looking through those Sword of Damocles, he was able to see a wireframe. And while he is turning his head around, the perspective of the wireframe will change accordingly. And this was a really crazy thing back in the days. And why is it only a wireframe? Yes, of course, it was because of the less CPU power.
Yeah.
But nowadays...
2015, it's 50 years later, and it looks a bit different today. So we have the HoloLens, It shipped 3 years ago, actually now, so it's quite old. And you can now directly see holograms, and these are not static wireframe things anymore, but these can be quite complex. And you can use it standalone. You can interact with your environment, and you can do crazy things with it. But before we have a look at all the things you can do with it, let's have a look at the HoloLens itself. And here you can see the first prototype that was implemented without all the neat and tidy-looking housing. And you can already see what is in it. So you see the cameras which are sensing the environment. You see the 3D camera, which is then trying to augment the field of view. You also see the lenses and the CPU as well. Holograms are in itself just, or in the sense that Microsoft wants us them to believe them, are just 3D models painted by light. So this is just a 3D representation of two 2D images that seem to appear like they are 3D models, and like you would normally see your normal 3D field of view.
Yeah, so let's have a look what means mixed reality, and what does it consist? We have on the one hand we have the real environment, on the other hand the virtual environment. So real environment, nothing is computer generated, just real environment. And the more we go to the virtual environment, the more computer generated information we will be merged with the real environment. So we have the augmented reality, the laser pointer is not working. The augmented reality, this means, and we have examples for that as well, that you extend your senses with additional computer-generated information. Like you can see, this is a quite usual example. Everybody of you will use this in daily life if you get some extra information what is next to your current location. We have some other examples because we just want to show you because they're really interesting. Have you seen the sandbox right there in the other room? This idea was inspired by the sandbox example, and here you can do some landscaping. There is a projector and a 3D camera over the sandbox. It will recognize the landscape of the sandbox, and a height profile gets just projected onto the sandbox. And here we can do some strategic things, it's hard to say, so that the tanks will fight each other. Another thing, it's in Finland, I think, right? Yeah. It's in Finland. Here you have a climbing wall, and you can experience some games. Again, a projector and a 3D camera. Here you have to stay inside the triangle. If you go outside, you will lose the game. So it's a really new experience with computer-generated information on a plain climbing wall. Normally, augmented reality means that you have a mobile phone in front of your eyes or head-mounted displays. Here are some examples, the Aether Air glasses, Epson Moverio, for example. There are building such AR glasses as well. And of course, and this is what we are talking about today, the Microsoft HoloLens. Yeah. Intel, of course, was creating hardware as well, but they discontinued Project Alloy. But this is an example for augmented virtuality right now. Augmented virtuality means that the real environment is not in the foreground, but the virtual, the computer-generated environment. But you land information from the real environment. Like in this case, you can see the real hands grabbing virtual objects in the computer-generated environment. So you see, you just go further to the complete virtualized world. Yeah, for this you can use Microsoft Mixed Reality HMDs. Mixed reality, to be honest, is not such a good word because, as you already recognized, if you have a look to Milgram's reality-virtuality continuum, mixed reality is everything which is in between of real environment and virtual environment. In this case, you have a closed headset with some cameras attached and a screen to see computer-generated worlds.
Okay, and now let's have a look at the virtual reality. This is actually the game Parrot Attacks VR that was created by us. And in this example, nothing real is in the game anymore. So the controllers are replaced by a shotgun, and the real environment is also not present anymore. So this is completely virtual right now. And yeah, for this we have lots of hardware, of course. So it starts with the cheapest ones, the Google Cardboard, which is free. But you just have to put in your smartphone into the cardboard, and then you can see things through virtual reality. Then the next more expensive option that you have is the Samsung Gear VR, where you also can put in your Samsung phone. And then we have the full-blown virtual reality headsets like Oculus Rift or HTC Vive, for example.
Yeah, so let's have a look to the HoloLens. So Thomas, maybe you can just show it to the audience. I will hold your microphone. So this is the HoloLens, and we want to have a nearer look onto the device. At first, it's a standalone device. So there is no need to attach a smartphone or something like that for CPU power because everything is integrated in this device. Here you can see a footage from the moment when the HoloLens was shown to the public, and you can see a smart software consultant, and he's just scaling a video footage on the wall. And yeah, that looks really impressive. And now we want to have a look how everything works. So the most important thing to mention is that we are having transparent displays. So to have a really nice augmented reality experience. In those transparent displays, we have 3 layers, RGB for the 3 colors, red, green, blue. And using a technique called wave guiding, light gets exposed by the light engines. And at a specific point, the light will go out of this layer, and then you have the impression that an image occurs in front of your eyes. Then we have the IMU, the inertial measurement unit, which includes an accelerometer, gyroscope, and everything, and it's really fast with update cycles of less than 10 milliseconds. Yeah, as Thomas already mentioned, we need a different kind of cameras. We need a depth camera, which is normally based on infrared, of course, and we need environment understanding cameras. So they are filming the environment and recognizing in which room we are. This is very, very important because if you place a hologram what are you doing? If you are placing a hologram in one room and you leave the room and you come back, at exactly the same position, you will see the hologram again. It didn't move a centimeter. Thank you. Okay, so what we want to mention as well is for the HoloLens, all the CPU power is included in the hardware, as already mentioned. Intel built a very specific chip for the HoloLens to make it work. It was the Intel Atom X5 with 1.04 gigahertz. It can run several hours standalone, so with the battery, I think 4 to 5 hours, I would say. It depends on the use case, but yeah, and it weighs around about 580 grams. And we have spatial sound. This means if you place a hologram which is exposing some audio waves, you can walk around it and you will have the impression that the sound just comes from the hologram. Awesome. So now let's go back to this footage.
Yeah.
Who ever tried a HoloLens in this room? Okay, okay. So what do you think? Is this true, what we are seeing here? The smart software consultant just so shortly in front of the wall looking at the video? Okay, let's have a look. We will clarify this.
Yeah, if you see this image, now you can see that the person is standing quite near the hologram right now. And in this distance, I would not see the complete image of the hologram. I would just see a small portion of it. So if I stand like this, this close to Martin, then I would see probably his face, but not
the augmented range.
The face could be augmented, but everything else would not be augmented. So let's have a closer look to it.
So if you see some marketing footage like the one before with the software consultant there, or if you see pictures like this is only half of the truth. Here you have a fully augmented reality picture, but in fact, using the HoloLens, only this small fraction gets augmented. So keep that in mind, but don't forget, it's a prototype. It's the first version of an AR class by Microsoft. We think that upcoming devices will have more augmented field of view.
Yeah, when it comes to the HoloLens, there's not just the displays, but there's also things like how do I control it? And there are 3 ways to do this. One is gesture control, so there are some built-in gestures that you can use. The most important ones are the bloom gesture, like this, which just opens or closes a menu, and then you have the tap, which is just a click. And then you can also have some variations using, for example, a drag, and then you release the drag again. And in addition to that, you have voice control, so you can, for example, say Cortana remove or something like that. And you have the gaze. So the gaze is not really eye tracking, it's not tracking your pupils, it's just the center of your field of view. So whenever you want to click something, you just center your field of view around the thing you want to click, and then you can do the tap gesture, and then you have clicked it.
So, now we want to compare the augmented Rift with the HoloLens. And we want to distinguish different techniques when it comes to augmented reality. So, the augmented Rift is using something we would say, we would call it video see-through. What does it mean? So you have your closed head-mounted display, you attach 2 cameras on it, and you are recording a video stream of the real environment. Using this video stream, we add some computer-generated graphics on it, and this gets shown to our eyes. This has the advantage that we have an augmented field of view which is completely 100% augmented. And the technique used by the HoloLens is a different one. We have those transparent displays. We can see through those displays, seeing the real world, and using computer-generated graphics and the optical combiner, we have the impression of AR, and it's called optical see-through. So now we want to show a Unity example how to program.
Let's try
an example.
Let's see if
with
it
HoloLens.
loaded correctly now.
Ich muss ins andere Netz. Okay, let's go. Yeah. So this is live coding right now, and yeah, okay. We want to restart Unity again.
So first of all, the standard Microsoft tutorials are based on Unity. You can also use UWP directly, but for an easier start, I would recommend using Unity first, and then going, if you hit some quality goals or some performance goals, then you can go for a full-fledged UWP solution without Unity. But at the beginning, it's always easier to use Unity. So, what do we need specifically for the HoloLens? The first thing we need is the camera should really be at position 0, 0, 0. That's the most important part for the beginning, because the camera will be the HoloLens. So wherever the main camera is, the HoloLens is currently. And if you put it in the initial position 001, then it's always somehow distorted. The next thing we need is we don't really need a skybox. So we have, normally by Unity we get a nice skybox, but we don't need a background because we have the real environment as a background. So that's why you just put the skybox on a solid color, put the solid color to black, and everything that's in the background and has a black color will be ignored by the HoloLens. So now, if we would now compile this, then we would see pretty much nothing at all. It would
only real environment.
Only the real environment. The next thing we need is a bit of quality settings. So if we go to Edit, then Project Settings, Quality, then we just need a very low quality level because everything else will be a pain for the HoloLens. So don't try to use the maximum levels. Delete everything but this. The next thing, or the last thing that is specific is, please go to File, Build Settings. And there we have the player settings here. And if you have a look at the XR settings, you just have to tick virtual reality supported, and it will add the Windows Mixed Reality SDK to it. So when you now try to access the specific SDKs, for example, for recognizing gestures, this will be included. And then actually you can build the solution. It will create a UWP, a Visual Studio solution, and this can be deployed to the HoloLens then. So that's pretty much everything you need to start. So it's not much. It has virtually nothing to do with HoloLens in specific. It's just some general settings except for the mixed reality setting. Okay. Okay.
Okay, so let's get back.
Yo. And
yeah, so with the Windows 10 Fall Creator update, some of you maybe recognized that because of long update sessions. The Windows Holographic platform was introduced, and this helps you a lot when it comes to development with mixed reality platforms or with the HoloLens. So, Thomas, do you think you are ready? Because we want later on we want to show the demo.
I hope so.
Yeah.
But let's figure it out.
We start with the demo at first, right? Okay. So, okay. Now the live demo.
Okay.
Hopefully it works. So this is our Star Wars phone holocom. No, I have to go back. Oh my God, to the right network. And this is there. Let's go. And then we try it again. So hopefully we will see a live stream of the HoloLens right now. Let's pray. Okay. 192.168. Punkt. Was? 1 und dann 2. Okay. Let's try it like this. Aha, okay. It's not secure. Yeah, you see, it's live.
Okay.
So we have a mixed reality capture right now. We go to low, live preview, and hopefully it works. Live preview stalled due to low bandwidth or loss of connectivity. Thomas. Okay. There it is. Awesome. Okay. So maybe it's a bit with a bit delay, but now I'm standing in front of a Kinect 3D camera right now. It's just placed there. And so we are recording an RGB video stream of mine and a 3D point cloud. This data gets directly transferred to the HoloLens. So what you are actually seeing is what Thomas is seeing in his HoloLens. And you see that he was placing our app inside the audience here. And now you can see a holographic representation of mine. I'm just flying over the audience. Can you see? And the cool thing is, you can do phone calls with that. So just imagine your best friend is on the other side of the world, and you have a 3D representation of him sitting next to the table, and you can have a glass of beer. Without prosting, but you know. Okay, that's the demo. Thank you. Now let's have a look onto the code.
So, if you really want to program that without just displaying things, and you want to interact with it, it's pretty easy as well. So this is what you can do in Unity. So you just create a new gesture recognizer, you attach a method to the tapped event, and then you say start capturing gestures. And then whenever this click happens, then the onTapped method is called. So this is pretty easy actually. If you want to have a look at the gaze at the object you are currently looking at, it's also pretty easy because it's just using standard Unity facilities. So in this case, we just need the camera position and the camera vector, which is pointing forward. And with this, we can then raycast into the scene and get the hit and use that hit. And that's pretty much everything. So it's quite easy to program, and there's nothing really special to it when it comes to the HoloLens.
Yeah. So.
Okay, so what did we use for the demo? In this case, we had two video streams that we needed. The first one is the RGB video stream. So this is just your normal, the normal picture that you get. It is segmented. This means that the background is removed. The Kinect camera and also the RealSense camera is capable of removing the background. But we also need the depth information from that. So if we have depth information and if we have RGB information, we can mix them into a so-called point cloud, which is not that easy because the cameras are not aligned. They have a different field of view. So there's some mathematics to it so that they really align. But if you have that, you can then use that to display the image. And here we see the final mesh that gets created. And you see Martin's silhouette. This is just the point, the depth information that you see. And the information in the background is just cancelled out because there is no depth information for that. And of course, we are also transferring the audio stream. So we are just using the microphone data and transmitting it via Wi-Fi to the HoloLens, and there it is displayed.
Yeah, so let's have a short look to some fields of application. So, of course, you can use all those technology for business cases like in automotive or medicine or whatever. But one of the first demos which were shown, and maybe you have seen this already, was the Minecraft thing on the table. Where you can just see those worlds within your field of view. But who remembers this game? Okay. Okay, this means you're really old, right? Okay, so these are the lemmings, and think what they here you can see what they have done with the HoloLens. So it's HoloLens, and it's crazy because you can just play your lemmings game, in your home using your sofa, and those lemming guys are just walking on the couch or wherever. And let's move forward so you can see how this bridge building lemming is building a track to reach the goal. Really exciting. Yeah, so what is the conclusion when it comes working with HoloLens? One thing is, and I was really impressed by the HoloLens when it comes to the responsiveness and the precision. You can place a hologram wherever you want, you can move around, it will stay on this fixed position. And this was really impressive, I think.
Yep.
Also when leaving the room and coming back, it was still at this exact position. Also when shaking the head, it's really good. But
yeah, the field of view is really a pity, because you have all these nice holograms and you cannot see them in full view. So that's the biggest problem that the HoloLens currently has. So if we have a bigger field of view, it is way more immersive, and this is also one of the things that the next prototype of the HoloLens will be good at. So there will be a bigger field of view.
Right. And there is another thing. It's the gorilla arm syndrome, because whenever you are using the HoloLens and controlling grabbing objects or something like that, your arms get really heavy after minutes of doing such gestures, yeah? And yeah, this is a disadvantage as well, so yeah.
So the overall conclusion would be, let's give it some time, actually.
Yeah.
Because the HoloLens is a good prototype, but it's just a prototype. So the next versions will be more immersive, will have a bigger field of view, lower latency, and so on and so on. And if we really want holographic displays to start gaining traction, then we need some time.
And currently there are hardware products on the market where we have an augmented field of view of more than 50 degrees or something like that, yeah. Okay, so ladies and gentlemen, our talk is over, so we hope you enjoyed it.
Thank you.